NAND substitution. There's a symbol for a NAND gate, and there's its truth table. The NAND gate is just the absolute opposite of an AND, an AND gate. Now we can do some clever things with a NAND. Firstly, if we take the basic NAND gate and we link the two inputs together, right, we have two possibilities here. With a 0 in there, we give us a 0 and a 0, two zeros, so the output will be 1. The second possibility, if we have a 1 in there, we'll have a 1 there, a 1 there, two 1s, so the output will be 0. So we've changed that NAND gate into a NOT gate. These two are equivalent. So the NAND is the opposite of the AND. If we take a NAND gate and then put an inverter on the end of it, again a NAND gate, that is the same as an AND gate. The third one, with no easy explanation, is an OR gate. This one you just have to remember. Okay. That is the same as an OR gate. These systems should be in your head. Now, if you have systems using ANDs and ORs and NOT gates, they can be simplified, and you can use just NAND gates to build the circuits. There are mathematical ways of doing it. The computers, some programs will calculate these things for you. We just need to be able to do it at a very basic level. So if you consider this system, where we have an AND gate being fed into, let's just say, an inverter, and then an OR gate. Okay. Two inputs, A, B, and C, and there's Z. So to do the substitution, instead of drawing an AND gate, you draw that. To keep it neat, you put numbers in your gates. Remember the wee circles on the NANDs. So that's A and B. So that was gate 1. Gate 2 is my NOT gate. So there's gate 2. Now we have the OR gate, which will be an OR gate. And the two inverters. So that's the OR gate there. So now we've got 7, 1, 2, 3 logic gates. We have 1, 2, 3, 4, 5, 6. But there is some simplification that can be done. If that's a 0 there, it should be a 1 there, it should be a 0 there. When you get a pair of inverters, if you invert something once and then invert it again, you're back where you started. So you can do without those two. And that's the system. Using 1, 2, 3, 4 gates. One more gate, but you've got to remember that on a chip you get 4 of these. So this system can now be built with one chip instead of 1, 2, 3 different chips. Okay, with all the different soldering that involves and all the space on the board that involves. Okay, by using NAND gates in the substitution, you can hopefully use less chips, so it's less soldering, and it makes the system cheaper to build and it makes it smaller. NAND gate substitution.